So, good morning. I'll go ahead and get started just because I don't want to keep everybody from lunch, even though I think there's a small break even after this. I know some people are expecting lunch right now, but this will be better or as good as maybe barbecue. I don't know, but so we're going to go over collection detection with flow data. If you were at BSides last year, you probably are looking at this thing, oh, it's probably like the same talk, and somebody's giving it at the same time, same place. But this is like part 2 of that. So my name is Jason Smith. I'm a Kentuckian, and I say that because it is important to me, because I've moved away. I've done a lot of work with the government, worked a lot with the Aberdeen Research Lab, or Army Research Lab, and with the base up at Aberdeen. And went to Charleston, South Carolina, did some work with the Navy there, with military health. But always I was trying to get back to, a place where I can drive around and not be stuck on a parking lot beltway the whole time or something like that. So it is important to me that I love this area, and it's the reason I love BSides Nash, actually. But again, I'm a car crazy kind of guy. The thing you see there is a death trap that me and a buddy built, which may be in this room actually, but love to build different things. So naturally, I also like microcomputing, things like that. I say IoT because it's a buzzword, but if you talk to me later and you're interested in like Raspberry Pis and a lot of things like the Omega and all these different things, putting in the internet and everything, I generally like to do it, but I don't really like the idea of buying a product that does it. On its own. I'm an amateur fry cook as well, so I love to fry anything. If you have anything you want to eat, I'm pretty convinced that if you put in some egg and put in some flour and some 360-degree grease and oil, it'll come out much better. The whole applied network security monitoring, shameless plug. We wrote this thing. We were analysts, still an analyst. I'm with FireEye right now, and I make detection stuff. So technically, the things I'm looking at maybe doesn't matter if I find them to be true positives, false positives as much anymore. But it really matters to customers, and so we are still analysts to this day, just for basically a lot of different companies now. But this book, 100% of all the royalties go to different charities. Specifically Rural Technology Fund, which Chris Sanders actually runs. It puts a lot of technologies in different rural schools and things like that that otherwise would not have coding programs. They wouldn't have after-school programs. They wouldn't have any kind of engineering programs for amateur engineering and things like that. 3D printers get put into these schools. All kinds of stuff gets put in these schools. We send Raspberry Pis everywhere. Great program, but we don't limit it to just that. We also donate to Hackers for Charity, Kiva, Hope for the Warriors, a lot of different charities. And if you buy this, again, all of our royalties go to it. Buy it from Amazon or something like that. Use Amazon Smile, and then more royalties and more donations go to it without you ever spending a dime, basically, outside of the book. So what's the agenda today? We're going to review kind of what I talked about last time, which is what is flow data? Why is it important to me to even be here to talk to you about this stuff? Because, when it comes down to it, there's, and I'll ask later on about the actual participation here on who is collecting it, but usually it's not a fair percentage, despite kind of industry-wide. People say that it should be kind of a staple as far as your data types, because it's how you pivot to the actual content of what's happening. But we'll talk about, again, why is it important, and some very basic things about flows. Last year was, 80% what is a flow, basically, and then kind of, oh, here's a surprise, here's our tools that are free and you can use them. This is the opposite. It's 10 or 20% that. And then I'll talk to you how to actually set this stuff up, and how you can basically, before the weekend's over, have this stuff up and running. So as a review, again, we'll talk what is a flow record. We talked about broad collection methods using Silk and YAF and things like that. And I'm going to also introduce FlowBat and FlowPlotter again briefly, but then go into how you actually use these tools. Again, if you want to see part 1, Adrian has those posted up. So what is a flow record? Well, it's more important to compare it to something that everyone knows everything about, and a data type that knows everything about everything, PCAP. So PCAP is, imagine you are some large cell phone provider, and you decide you want to record everyone's phone calls that they make all the time. Well, that would be a lot of data to go through if you wanted to figure out who was talking to who. But it should be really easy because they don't do that. Well, I don't guess they do that. Instead, we just have phone records, and we see, okay, well, I can deliver this to the customer, and the customer knows exactly who they talk to, and the phone company knows who everyone's talked to and when they talk to them. Well, that's a flow record. That's the context of a flow record. The storage requirements for flow records are literally mountain versus molehill when it compares to PCAP. And specifically, so Mount Everest is 30,000 feet high, right? I am not 6 feet tall, but I'm nearly 6 feet tall in comparison. And so 0.02% of a PCAP could be considered a flow data as far as or a flow record. Or actually all the flow records. If you convert a given PCAP, you're looking at 0.01 to about 0.03% of it. So roughly 0.02% on average. So the amount is, it really goes into, how much storage are you investing in PCAP? If you're only giving it a day, well, that's a huge amount of flow records by comparison you could also be storing. Not to say you should have one over the other at all, but one will, you'll see, end up pivoting into PCAP and show you exactly, what PCAP I'm actually trying to pull. Another good comparison, so this big truck and that little man there, well, that's pretty sizable man, actually. He's not 158 pounds, probably, but maybe with his jacket or some flow app labeling or something like that, he's a little heavier. And so, by comparison, that's your flow record versus your PCAP record, storage-wise. Another good one, not completely accurate, but instead, 6 of these trucks versus a Caterham R500. Very zippy car, does whatever it needs to do really fast, versus these big dump trucks, which they do everything they should do, but it's really hard to really manage these things. But they're needed. So flow data itself, we often call it flow records or session records or net flow records. Cisco owns the term NetFlow, so when you say NetFlow, you're advertising for Cisco, which is great because NetFlow really made all this popular, especially like NetFlow version 5, which was the most basic really, even though it sounds like it would be 5 versions up, which it is, but it was really how everything really got pushed out to all these networking devices. But then out of nowhere, everyone wants to generate their own flow types, and so there's IPFix and a few more I'll talk about in a minute. But flow data is a summary of network communications. So again, it's say again? Yeah, there you go. It's so imagine you have all of these, we go back to the phone records themselves, just a comparison of who's talking to who, how are they talking, and when are they talking. In this case, the source IP, source port, des IP, des port protocol. We tag on some times because otherwise they wouldn't make sense. They wouldn't be useful. And then we run a lot of statistics against them, which is where it becomes really useful. So you don't have the what, but you have the who, where, and the when. The why is always up to the analyst. So in the end, you have everything you need to get where you're going, but you don't have what you need, but that's not what flows are about. So we have this 5-tuple, we have timing, and we have data, and really that leads to some statistics that will, in the end, give you some good collection detection metrics. So building a flow record, last year I talked about the factory, I gave a little dinky example about it. I won't go into detail too much about that, but again, it's a 5-tuple. You get some sort of data input. It's technically converted to some sort of flow maybe. It goes to a flow collector. We say, oh, is this new? Well, if it's a new source, dest, IP, or source, dest, port, or protocol, then it might go to a new record. Well, if it's not, then it's going to go to an old record, assuming that old record hasn't timed out, because you're not just going to keep a record open and constantly calculating nonstop. Those were the terminations. So instead of the factory example, we put packets in these baskets, these flow baskets. We're going to call those flow records until they stack up to a certain amount, and then that's that. We send it on, and we can query it at that point. So, excellent movie. I should make a Buffalo Bill, infosec parity account. Would be excellent. I'll probably run out of ideas quick. So how do we actually generate and collect network flow data? This is getting more into the bulk of what are we actually doing here. Why is this part 2? And I'm saying the same thing over again as last year. So who here currently uses flow data in their environment? No more than that, because I know 2 aren't raising their hand. But who here, it doesn't even make sense to have flow data in your environment, I guess. Who is actually doing some sort of defensive, any kind of defensive role? Okay. So
my environment's all public web servers.
Say again?
My environment's all public web servers. The flow data would be
oh yeah, I guess.
different.
Yeah, that's true. So, how do we generate flow data? What is involved? Well, usually people think, oh, well, you need to get your NetOps guys to take their routing equipment, put a little more load on them because it's not too much more, and send you some stuff. Well, you'll get a lot of pushback a lot of times from network operations. Sometimes you won't, but sometimes you do. And so you're asking them to basically make some changes to some networking devices. Well, I usually tell people that, especially from a defensive architecture, that if you already have a tap that you're generating alerts off of anyways, you could probably also generate NetFlow off of that. And because it's so small, it's so easy to do, why should you ever not do that? So you can set up like fprobe or YAF or something like that to generate off of that tap, and you'll have all your flow data. And I'll show you just how easy it is in a minute. So there are multiple types. Again, we talked about NetFlow, Cisco NetFlow. IPFix is what YAF generates, and that's what we'll talk about mostly today. But there are a lot of different kinds of flows. There's JFlows. Hold on a minute. There are JFlows. There are S-flows. Everyone has their own little proprietary name for them as well. So popular platforms, how are we actually going to generate all of this NetFlow data? Well, we'll use Silk today, but I don't want to end with that and just say that Silk is the only thing. There's Argus, which is already built in Security Onion. So if you're in this room, you probably have a Security Onion box running somewhere, or you've set one up. So if you knew it or not, you grazed by a lot of NetFlow data for your own NetFlow data. But there's also NFDump, which is very popular. It's been around for quite a long time. There's a graphical suite for that as well. Then I say those are raw NetFlow solutions, as in those only are flows. In the other case, there's general log aggregation solutions like Splunk or the Elk Stack. So people, I love Kibana, and Elasticsearch is really awesome. But we'll talk about where that makes sense and where it doesn't make sense. So your raw solutions, again, let's go with the cons first. Again, I said they're only flows. You may be able to extend it and add some metadata into it. Argus does a pretty good job about that, but some solutions don't. And the one I'll talk about today doesn't do a great job about that. It takes a little bit of extra effort. It's not too easy. Despite being fully configurable, it just takes some work. And not all solutions are equal, and that's a prime example. Argus is different than Silk. Silk is different than NFDump. So it's like you have to pick which one you want, but if you don't have any of them, then any of those are better than what you have. Some pros of it. So you have storage and retention. Again, I say that they are so small, flow record-wise, that they're 0.02% of a PCAP. Well, that is a stat from raw flow solutions. That's not a stat from you send the flow to Elasticsearch, and an Elasticsearch is 0.02%. That's different. So your raw solutions match up to be really small, so you get good speed over ranges. Tools like Silk, they do kind of a flat file format as far as how you actually query these things. So if you say, I want to query 3 years ago, some data 3 years ago, it's not looking back 3 years. It's just saying, oh, well, there's a directory for 2013. Let me just go there and find this timestamp. That's it. It's not having to look through a bunch of archives or anything like that. And so the ease of use is also, I would say granted, you get used to different log solutions, especially things like Splunk. They're really, really good commercial solutions. They are also pretty easy to use once you get used to them. But when it comes down to it, a good command line solution that is also easy to use is pretty impressive. And Silk, for instance, has the best documentation of any tool I can think of. So it's really easy to use, especially once you get in trouble, you're out of it really quickly. You can just easily look it up and it's done. Hardware requirements, again, because it's so small, even extremely high throughput links, it's pretty easy to work with, unless you're maybe like an ISP trying to do it with everyone, like a mobile ISP or something like that. Then you might have efforts, but I don't see it being an effort for almost anyone. I mean, I've worked in very large organizations, and they were easy as cake to generate net flow for everyone. This is unsampled net flow. And that's another topic altogether, but unsampled net flow is what we're all wanting. We don't want sampled stuff because your stats won't be accurate. You won't really be able to use it for instant response or anything like that. And I understand it's difficult sometimes, especially if you aren't generating it on your own and you're telling NetOps to send it from a router. They may only have the option of sending you sampled net flow records. So again, it's another reason why I say send it on your own. Log solutions, and I know it's debatable, and maybe it'll be debated here, but Right. So actual like Kibana and Splunk and things like that, those are really, really, you can extend those out to do basically whatever you want to. Like a pivoting and things like that are awesome in tools like that. So you can really pivot to the data you want. And when you have other data sources, it's the best thing ever because that's the whole point of flow records right now, right? The reason I'm here is to tell you they're not the end all, but they'll pivot to where you want. So if you can pivot to the right data, that's great. And more so if it's a centralized data source like Kibana or Splunk, you go straight to it and it's great. They're also, despite not being a binary format or anything like that, it's really quick to parse, they're still really easy to search and really, really fast. I even had records that were searching faster than Silk, which I didn't think would be possible, but Elasticsearch is extremely fast on that. The only downside is when you go a distance to pull old data and things like that, it may be slower, significantly slower on archived results. The big cons of log solutions, outside of maybe cost, because we talk about Splunk again and say pay for tools that are considering your log amount coming in. Well, flows, there are more flow logs than any other log you'll have. So you may run into cost issues, which I didn't put here because it may not be the issue with things like Elasticsearch. But your reliability and maintenance, they kind of go hand in hand, that you aren't going to have as serious of a maintenance and reliability issue with raw solutions that you will with something like Elasticsearch. Because it is made to have everything put into it, it's going to be doing a lot of work. And so you should really hope that your hardware is spec'd out, which is, again, the third point. Because if it's not, you may have a lot of maintenance issues that you're having to constantly go back. Also, there may be storage issues. We talk about how small flows are, but people considering a stat like 0.02%, that's small, but it's not for things like Elasticsearch, and it mounds up. A good perspective on this is this little dinky pie chart. So this is a comparison of the same data generated at the same time on a Silk instance and Elasticsearch instance. The difference here is that Elasticsearch, in its default format, and that's compressed and everything, uses 28 times the storage of a raw flow solution like Silk. That's with NetFlow version 5 data. This is just a quick little tool I threw together to generate 4 million flows. And I was spacing them out so that I wouldn't have any loss. So you don't have, it's virtually lossless on both sides. The numbers match up, but yet, again, you get 38 megs of data for Silk, and you have tons of data for Elasticsearch that you're having to store. So again, this is simultaneous generation, and the tools they're available as well to actually do the comparisons. So how do you actually get started with flows? The bulk of all this. A lot of people steer away from flows just because it's like, again, it's effort to set up. It's like, we have to ask, network operations, or we have to do our own stuff. And a few years back, that was kind of difficult because there weren't just easy tools to just spin up. But then over time, Logstash was super, super easy to set up, and people really gravitated towards Elasticsearch-based solutions. And I really do chalk that up with a lot of the success that people have had with flows. So I don't want to come away here and think that I'm hating on Elasticsearch, because I'm not, because it really has really opened people's eyes to, I can easily do this. But in the end, it's really needed, we all really need easy, raw solutions as well. And so there's Silk, which has been around forever, really. It's Argus came out before that, and from my understanding, I mean, that's Argus was like 1985 that they were working on that. So it's been forever, and in 2003, all that stuff really comes from the government, and it comes to some people, and they say, oh, well, we'll make it public, and people can use this. Well, it's still incredibly hard to use, and Silk at the same time came to the public, and so you had options, but it's still really hard to set up. But that's not the way anymore. So we're going to talk about Silk and Flowbat. Silk, which is the back end that Flowbat queries. Silk will generate all your flows. It also is all the flow analysis tools. Flowbat is interpreting what an analyst wants to do, or what a network operations analyst wants to do, and sends it to Silk, and returns back, and it makes something pretty for you. We also add in a ton of analyst enablement features to Flowbat. Basically, when I say analyst enablement, an analyst needs to be able to pivot stuff easily. They need to be able to not do a bunch of like UTC conversions and stuff like that across data, and they need to be able to do all kinds of different things that they normally can't do. I mean, a good example is like field interpretations. A junior analyst, he may see a protocol of like 6 or something like that. Well, he's like, oh, this 6 protocol. He's not even grasping, what protocol that is. And so we interpret that. We interpret a lot of ports and different things like that based on like Etsy services and stuff. And so it'll come to the analyst that they'll have a better idea without telling them, one way or another that's what it is. Because, again, the why of everything is still up to the analyst. No tool will be able to do that. How do you do this? Well, Silk on a box and install Flowbat Ubuntu.sh. Those 2 tools will get you going, and you'll be done. Unless you have a very distributed setup, you won't have any more work. If you tell it, the tap that you're using or whatever, it'll be done. If you have some odd network, you may need to set it up differently, but it basically interprets, what's local, what's not, things like that. And I'll go into that here in just a minute. Your total time, though, is 13 to 15 minutes on getting your flow solution up. And it's a total of like 4 questions. So you really just walk off and it's done. So Silk, what is it? It's the System for Internet Level Knowledge. Again, pretty old now, but still pretty awesome. They update it all the time now, more so than they ever have, at least the publicly facing versions. The NETSA guys did that, and there's a link at the bottom. They have all kinds of awesome tools down there. But today we're going to talk about Silk mostly and YAF. YAF is the generator. But Silk itself, there are 2 main suites. There's Packing Suite, which actually says, what's a flow? We're going to determine what it is. And then there's the Analysis Suite. So the Packing Suite took in flow data generated from fprobe or something like that. And then the Analysis Suite is for the analyst to actually filter through the stuff or generate stats or, count how much is, for a given time. And we'll go through some more details in Silk and Flowbat on that. Again, the documentation's there. It's the best ever. It's completely overwhelming at first, but as soon as you have an issue, you go to that documentation and you're like, oh, I realize that the answer is right here. So what does an architecture look like in its most basic form? Here you may have 3 sources of flow data. You have an fprobe sensor, a YAF sensor, and maybe a router or something sending flows in. So you have 2 or more different types of flows here, because fprobe again is version 5, NetFlow version 5, and YAF is IPFix. Well, RW FlowPack, which is part of that packing suite, will take all that in with little configuration and go ahead and say, oh, well, I understand what this is. Let me document it out, and that's that. The analyst can then either SSH to that box, or they can use Flowbat, which may be sitting on that box, just go to it from their browser and get all the data they need. So it's pretty easy. Hence the reason the tools are pretty fast to set up. So getting started, again, I won't review this too much because I just said it basically. Routers and switches, if you got them, and they'll send unsampled flow data, great. And if you don't have people fighting you for it, that's awesome. You should stay in that job because you have an awesome NetOps team, and they probably like you and you like them. So if you don't, or if they don't want to, or if you want to make it easy on them, I always recommend that people control their own flow of data if they can and when they can. So we have YAF or F-probe that works off of some sort of interface that's pulling in all that data off the tap. You have your Silk server, which again I'm going to talk about Silk on a box and FlowBat here. It's going to just take all your data in. The analyst will look at it. The analyst will look at it by either going directly or going from his browser or her browser to FlowBat. Again, if you have separate sensors, sensors.conf and silk.conf in Silk are what you'll need to edit, but even that's really easy. So the actual install, it's 3 lines, and that's including getting it from the internet. So you run these 3 lines, you answer a couple questions like what interface are you using? Do you want to run it on boot and stuff like that? And it's done. And that includes, we have an Ubuntu installer and an installer that should work for Red Hat and CentOS and stuff like that. And so if you install that, just answer a couple questions and go get something. So in 5 minutes, for instance, like go get the mail, right? Let's see if I can actually. If you have epilepsy, look away. I'm serious. Well, that didn't play at all. So I'm installing FlowBat. You can see it up there doing its thing. It's running. So I'm looking around at some stuff, playing with the cat. I'm going to go get the mail. Not a huge fan of my neighbors right now. We're getting new ones, so I'm pretty pumped about it. Play with the cat again. It's a Bengal cat, by the way. Love them, but if you have kids or it has claws, don't ever get one. They're so well, we're done. So we're done with Silk. It's queryable right now. If you just browse wherever, it'll be generating records and you'll have flow records. So it's literally that easy. I just ran 3 lines and boom, go get the mail and you're done. So that was on a clean Ubuntu box with no prereqs installed or anything like that. So it installed all the prereqs you need. You don't have to do anything. So Silk analysis. So we have it installed. Well, what do you do with it? Well, the first query there, it just runs a basic query against all protocols. So why do we have additional stuff? Well, Silk and RW filter specifically requires an input and an output and that middle partitioning switch. And that's basically your filter itself. So you'll say, I want all protocols, and that's obviously all data. And so you could also do like outbound. So you want -- type equals all, or you want outbound data or inbound data. You can select those, but it'll pull the data you need. A more advanced example, but still not too advanced. The bottom one, we'll just take like a week's worth of data, and it'll say, well, if any, based on a certain country code map, if either source or dest, it relates to China, and if source or dest is this local address, then we're going to go ahead and pass the records on to this RW cut, which converts that binary format into a human readable format. In this case, we just give it these fields, and so we'll have the 5-tuple with a source time. So it's pretty easy to work with, but as you can see, it can get kind of complicated. And in the end, especially when you have times and specific times down in those dates, it kind of gets really complicated. There's a fair amount of calculations that are involved. Also, this is for brevity, but I've split these up into different options. Otherwise, one big line, it would be stretching across. So you can also do things like PCAP conversion. So here I'm pulling a PCAP down and converting it to an RWF file, which is just something I call an RW filter file. You can call it whatever you want. But from there, you can just view, again, we've said view all data, basically. But I also specified that malware.rwf, and that's going to show me all the flow records. In this case, it's like SDBot or something like that I pulled, some kind of malware. But it's a good example of how this data actually, you can take any PCAP and do this kind of stuff. It's still a little bit involved because obviously there are several commands. But it's pretty easy to do, especially if you want to script things like this out. That's the biggest, I would say the biggest takeaway of this talk may be that Silk is awesome for that, even though I'm going to steer away from it for basic analysis. Another example, this is how you run some stats. These are basically just some easy top 10 stuff. In the first example, it's like your top protocols. There's probably not going to be 10 there, but it's your top protocols that it finds by bytes. So it sums up every flow record. It says, oh, which one of these had, protocol 6, or which one of these had protocol 1. Sum all the bytes for every single one of those, and then give me a table of some records. more advanced one again is below it. It's top sip dip pairs for valid conversations, at least the valid conversations you're attempting to find, so that you assume that there are handshakes and whatnot, and they continue talking. But again, we speak it out like we would speak it in a sentence. We tell RW Stats we want the top 10 sip dip by bytes. So it's pretty handy in that way that new analysts, you always tell them, well, what do you want? Like, tell me in a sentence, what do you want out of this data? And if they can answer it, they can probably generate this kind of query. It may take a little bit of work on the syntax, but we kind of get rid of that with Flowbat quite a bit. Examples of outputs, these just don't really relate to anything, but it's a good example. RW cut by default looks kind of like that. I've narrowed down just to a little less data than you would normally get. But RW Stats, a table might look like that for some application records, which I'll talk about in a minute. And then you have RW Count, which bends things up by default in 30 seconds. So for this amount of time or whatever, which is very little data here, there were like 1,380 bytes in that time span, and then 1,763. So in your head, you can say, I see where you may be able to like graph this stuff out. Oh, go ahead. I don't think they have yet, but there's the analysis pipeline, which is a different thing that the situational awareness guys have, and it's pretty awesome. Like, they constantly update that, and I can't tell you if it does or doesn't, but if I had to bet, I would say that that's where that you would end up finding that. Right, or you could pretty easily write something to do some conversions. Yeah. So Flowbat. So that was Silk. Flowbat, again, is just the front end of Silk, basically. It's not officially the front end, but Chris Sanders and I wrote Flowbat because basically we worked out of Silk forever, and we did more time training new analysts on how to use it than we did anything else. And we wanted something that the analysts could just use, and that we wouldn't get irritated doing these time conversions and figuring out all these things down to like the milliseconds on how, when does this flow versus when does that flow. With Flowbat, you don't do any of that. I mean, it does it all for you. And an analyst can just easily do anything they want to. Autocomplete and all that stuff is there. So how do you get started with Flowbat? Well, there's some links up there that'll take you to some details about it. Flowbat itself has some help inside it that's not available on flowbat.com. But you just grab it from GitHub. Do kind of like what you did with Silk. If Silk is working, then you can expect Flowbat's about to work in 7 to 9 minutes from now. So you have these install scripts, and then you just go to wherever you installed it at port 1800. Or if you decide to run the HTTPS script that we have as well, it'll set up HTTPS for you. But I recommend, obviously, disclaimer. Check it out. It's me setting up your HTTPS stuff. So obviously look at the script before you just run it. Even though I didn't put anything malicious in it, I'm telling you that at least. But trust but verify is the keynote. If you were there, Don't trust me. Trust me, but verify what I'm saying.
Just like last thing, bro. Just run this.
Yeah, it's cool. Yeah, trust. Yeah, it's all right. You'll be more secure.
There's the shell command.
Right. So how do you install Flowbat? This is kind of the same old song and dance as before. You just do kind of the same thing, but a different script, and go get a drink or something. Let the fizz go down, and it should be basically done. So 7 to 9 minutes. Again, we have installers that should work on Red Hat and a few different things as well on top of just Ubuntu. So again, if you have epilepsy, it's a hair longer, but not much longer, you will have a seizure. Well, this would work for me. So in this case, I install Flowbat. I'm doing the same thing. I only have 2 questions to answer in this case, and it's going to do dependency. I love to fry food. I just said I did. So here I'm making a chicken brine, and I'll include the recipe later because it's if you like Chick-fil-A's chicken nuggets, you're going to like these a little more. So manage to easily make those. I do what's called pressure frying, which is you do the same thing you would normally frying, but it has this big steel lid on the top of this big huge pot, and you crank that down as much as you can so that it won't explode, and then it goes for like 2 minutes. It's so fast. But it goes for 2 minutes, and then you're basically done. You have Chick-fil-A chicken nuggets or whatever you want to make. You fry anything in this thing. It's great. So here's basically, well, we're done. Can't even go into any more detail. I'll show you at the end the recipe. But in the time it took to make half a chicken brine, Flowbat's done. So that was like 7 minutes, and the first one was technically like 4 minutes. So while I said it was like a 15-minute thing, it's more like 11 minutes, depending on your internet connection, which was recently upgraded at the house. Awesome, for free. Time Warner Cable coming through. So what are some basics? We have Flowbat now. We have Silk now. We ran some basic Silk stuff, maybe while Flowbat was running, or we made chicken or something. But now we're going to run some Flowbat stuff. And this is the kind of the more, I guess, the more in-depth stuff that I want to talk about today, because it's the actual analysis of this. And so here, this person, who knows who this was running these things in case they made a mistake and they didn't see it. But here I'm just saying, I want all protocols. I want all data. This is what I did with Silk first, and I'm doing it with Flowbat now. And so notice I don't have the input or the outputs. Flowbat understands that, okay, well, we're doing the same thing over and over and over. If we're changing it up too much, then I won't be able to validate the input anyways. So I'll always have these same things, unless in special cases where you're including things like PCAPs. But in this case, again, we make a nice little table. That table can kind of do whatever it needs to do, and that's all your records for the current day in a, they're not all stacked in one page if you go through the pages. That's common filtering. So another thing, it's the same example I showed you before. In this case, the NECC is left out of this query builder, but we can still add it as an additional option. So I pick the times that I want. Don't worry about formatting and stuff, it does it for me. I tell it that I want this this local range, and you can use just IPs or CIDR ranges or anything you want to use. Or if you'd wanted to make a set of IP addresses, you could do that. And then I add in some additional options here. In this case, we're doing NECC. That's the source or dest as it relates to this country code file. And then I run it, and it's a week's worth of data, so it may take some time, because this is actually on a different box than I just installed on. But it should be pretty fast compared to almost any other thing. So yeah, it's all your data. And you go through different formats. It's 25 per page. But let's, we narrowed it down earlier to just the 5-tuple and the source time. So let's go ahead and do that here. We just take out these fields. There's no need to be rerunning these things. But we want our source time first. So we just move it over. So it's a pretty neat little web app that takes out some of the complications of having to rerun things over and over and over, or resave things over and over and over, and keep up with sets and whatnot. The basic analyst, they understand this. I mean, I've given it to people who they literally have almost no concept of flow data. It's like, oh, these are like phone records, where like this is your number here. And they can generally get a good idea of this. You give them a few challenges, and they understand it. So I always take a lot of return input and some different feedback from people on what could be changed, and we try to change things as much as we can to people's liking. Usually adding features and things like that, or any bug fixes, which there have been a lot, but those are pretty much narrowing out. Hopefully, don't go attack it as much as you want to. If you do, please tell me the bugs. It'd be great. I'm sure there are vulnerabilities or anything there, because I'm not this full-time web application developer. So this is just something, again, some analysts wanted, and we made it happen. And a lot of people are using it now, and they really like it. So we get a lot of responses, and if anybody uses it here, please feel free to write to us. So here's some stats. If you're watching, I basically just ran a source dest IP pair comparison. So we went to the query builder here. I don't even worry about anything, because by default the query builder is understanding that, we want all protocols. So you can literally just go to query builder and just run it, and you're going to get all data for the current hour. But you'll notice I changed that to the current day, and we say we want source and dest IP pairs. We want it by bytes, and there you go. So easy as cake. Another one, we talked about bins, and I talked about how it looks like you could graph that. Because it's very handy to have a good line graph or something to show you total data of how something's reacting or whatnot. So in this case, we're going to do a rolling day. I say it's a rolling day because we're going to talk about a dashboard in a minute, and that's kind of important to have, periodically executing data that's constantly in a dashboard that keeps rolling over, because otherwise you would have old data all the time. You have to refresh that. So in this case, we don't have to do that. This is way too in-depth here, so we knock down the whole bin size. Like that was like a 30-second bin, and so let's do like a 10-minute bin, because it's a whole day, and that was too much data to actually pay attention to. So this is bin by bin, how many bytes and packets and records do we have. We save that as a new filter, like I said, a new visualization. In this case, we're going to call it 24-hour outbound data, because you'll notice there's types as well. We declared outbound, any out web data, any out ICMP. Those are classes that Silk considers. And so we go ahead and allow that here as well. So in the dashboard, what do you do with that? So you see your 24-hour outbound data. It's done. Throw in the dashboard, but let's make it get to where it periodically executes. So every hour, we should have new data there. If you don't want all that, you can go here and just narrow down some stuff so it normalizes that graph to something that makes a lot of sense. Your axes will change as needed. Unfortunately, the date axes look terrible on there, but you know, what can you do? You can mouse over wherever you see anything, and it'll clean it up for you. So, you know, an actual decent example of what's going on here. Well, so some non-standard ports. It's awfully helpful to say, oh, well, how much outbound data do we have going to things that we don't really expect it to go to necessarily? We're just doing some discovery here. It's really basic analysis that maybe isn't always obvious to people that, this may actually prove some fruitful stuff. If you're in a very large environment or you don't know what your environment is, it may not be fruitful. You may see all this stuff and you're like, oh, this looks like it may be suspicious or something. I don't expect this to happen. But just because you don't expect it doesn't mean it's bad necessarily. So I recommend that this be used, in cases where you're not going to go overboard or something. This is obviously very small bit of data here, but it does show at the end that there were 5 distinctly different HTTPS services that were reached out to, and I say distinctly different as in they all operated off of distinctly different desk ports. Right now we don't know what those are, but it's a good example of your stats on how many odd things are there. I did throw something in the additional options. Silk, again, they take plugins. Anybody can write anything for it. I don't want to compare it to like bro scripting that like you can literally do anything with, but you can do a lot with some Silk scripting as well. In this case, there's this app mismatch, and this uses a thing called app labeling that is kind of separate to Silk because I'm using YAF to generate all these flow records. YAF tags on some app labels, and these app labels do a little bit of packet inspection to say, what is this traffic? Like, what do I expect that this traffic should look like? And it has all kinds of little signatures on how it should expect these initial packet payloads to look. And then it tags it. It says, oh, this is HTTP, or this is HTTPS, or this is whatever. It's not perfect, but it does a pretty good job of giving you, I would say they've tried to eliminate false positives in it, and you'll probably get more true positives than that. I can't go too much into detail on it because personally I don't know all of their secret sauce in it, but it is open source, so it's not really secret. So if you want to tell me what it is, I would greatly appreciate it. Moving on, identifying services. It's really helpful to know what you have. Again, I said if you don't know what you have, then some of the stuff won't even be useful, but that's the idea of NetFlow data, right? It's going to tell you kind of what you actually have going on. Network situational awareness is the group that made this thing. It's all about situational awareness. So let's identify some HTTP servers and HTTPS servers. So if we read left to right on that final query, we include that in FlowBat in case an analyst wants to go to Silk and automate any of these features. They can take that final query, which looks very terrible right here, but it's because the calculations were all done. So like on active time, you see that it's this huge active time on here, but that's all just calculated in on these rolling time periods. But in this case, it's a pretty easy query that we just say, we want anything that's a source port that is 80 or 443. This is like your common analyst doing this kind of stuff, right? And they say that they only want things that are, outbound or just any kind of out data or any kind of internal to internal data. And so, yeah, you got some stuff here. These guys are running some sort of HTTP or at least port 80 or port 443 data on these different source IPs. So we've counted up bytes, kind of a going trend that you'll see that I do, because I think it's kind of useful. But it doesn't do a great job because, we talk about app labeling, and, in this case, we're doing a week's worth of app labeling, and we're trying to generate, based on those packet payloads, what is actually going on here. And so, from left to right, we had the same type, this out web, int to int. So it's anything going outbound or anything internal to internal. We have these same times. They specify, this rolling time. And we've said, well, okay, what flags do we want? So this goes into a discussion of unidirectional versus bidirectional data. Bidirectional being it coalesces replies and responses together, and then unidirectional being a flow that comes out. It's a source IP, source port, des IP, des port, and protocol. Well, when you see the other record, it changes that around. They're flip-flopped, right? And so it's a new record in a unidirectional sense. So with unidirectional, you have a reply and a request, two different flow records. With bidirectional, you have one flow record that is we'll take, again, a bro's a good example, like the bro con log. You have originating host and a responding host. And that's to give you an idea that this is where it originated, this is who responded, but don't think that that's one packet or one flow record in a unidirectional sense. It's bidirectional. Silk is unidirectional, so we specified we want initial flags. It does not talk about the initial conversation flags in this case, but the initial, reply conversation. We basically say, well, we want to reply or anything that is the SYN-ACK, the initial SYN-ACK that's coming back. And so in this case, we can try to eliminate false positives. We may be missing some true positives here, but in most cases, we have a lot, or at least most of what we expect. You'll also see there are many more than what we had previously. But it's not too unexpected. We talked earlier where I'd ran a little query that said, oh, well, there are distinctly different HTTPS destinations. Well, in this case, you see that we have this 902 and 443, and we have 444. Well, in this case, I was running some vSphere stuff, and vSphere it gets interpreted as a lot of HTTPS traffic. In fact, it's by default, I guess, when you deploy an ESXi box, you'll have two HTTPS servers both running non-standard ports, and so that's the case here. Analyzing PCAP files, you'll see this is not just that. Well, it technically is inverted colors, but it's like a night mode in Silk. So we use WebKit to invert your colors if you want to. A lot of analysts at night don't like looking at a white screen all night. And instead of having some sort of unapproved plugin or something like that in their browser, we secretly hide that unapproved plugin in Silk, and then they can use it. I'm just kidding about it being unapproved, but it's just like a little WebKit thing. So if you're using, I guess Internet Explorer doesn't use WebKit, so if you're using Internet Explorer, you won't even see the option for night mode because we do an interpretation of, do you have this or don't you? Well, if you do, show a button. If you don't even tell the analyst that they even have the option, because they'll just click it a bunch and it won't work. So in this case, we're going to analyze some PCAP files. This is a really quick example because I throw in some exploit kit traffic, and this did all traffic here, and that's how you do PCAP. So previously, again with Silk, it was several commands. In this case, just drop a PCAP in here, and it'll look at it. But you have to have permissions, obviously, to view that directory. This also has to be on the box running Flowbat, which is the only downside right now. In the works, we're working up a upload PCAP or something like that, so that then you'll upload to one destination and it'll always be queryable. In this case, obviously, you see some of the traffic here. So automation, this is really fast. These are things I didn't really talk about today, but things that are worth it in the slide, especially reviewing this kind of stuff. There's that analysis pipeline, by the way, which is pretty handy. It does all kinds of stuff like beaconing detection, all kinds of things like that. There's also Flow Plotter. Flow Plotter is a tool I wrote a while back that does some graphing that Flowbat can't do. Namely, we started by doing some, bar charts and things like that. Flowbat, well, Flow Plotter does a little more. It's all written in Bash. It's all tweakable. I use these templates basically to reference a lot of D3 and Google visualizations. Browser independent, so it works in everything I've seen it in. And all the visualizations come in an automated fashion. So you could automate this if you wanted to through Silk. just little pictures of some graphs. I won't go into much detail on them, other than you see someone moving around a little bit. Namely, so you have obviously your bar charts, column charts, pie charts, and line charts. But you also have this little middle guy here, this little tree that keeps on expanding. Well, that's automated asset detection. So you run this flow plotter there. It's going to run through all your flow data, generate this flow map, or a tree map of all of these assets that it sees. So you won't be running this thing to do the discovery. It just does all these silk queries and then throws it into this little tree map. And you're like, oh, here's my web servers, and here, any mail servers and things like that. Bottom left is a bubble chart, which is like a 3-axis thing that compares records versus bytes versus packets. Again, we looked at RW count. You saw 3 columns. That kind of compares them. And it does it, per host and different things like that. So it's pretty useful in trying to get an interpretation of how do you expect things to work. But it's kind of hard to interpret, and it's definitely hard to give to someone else for them to interpret. We have some timeline stuff, which is like some Skype traffic, and then a pretty useless force-directed chart until you show it to someone else. And then so that's the thing, right? So you color code some stuff, and it's like, I don't make any sense of this myself until I move some stuff around. I'm like, look, manager, I'm telling you this is happening because of this. And they're like, well, you have a graph. You must be right. And they're bubbles and they're moving around. This is very interactive. Go back to work. And so, in summary, Silk, really fast, best documentation ever, tons of analysis tools. Flowbat, again, like practical packet analysis and applied network security monitoring. Chris wrote practical packet analysis because that's what he was doing. Then he says, hey, let's write this other book. And we wrote that because that's what we were doing. We want to help people. That's why we did Flowbat as well. We're not trying to push it on anybody, despite me being here talking about it. But I'm not telling you a price tag or anything like that, so it's like, you just go download it. And so it does rapid pivoting and things like that, visualizations, and we're constantly working on it. So any bugs or anything, we respond daily. You send me something in the morning or late at night, a lot of people, and I'll try to respond in 24 hours. It won't be fixed in 24 hours in most cases, but I'll respond and get on it. Conclusion, use it. Flow data, if you're not using it, you definitely should be, especially if it makes sense in your environment. Collect it. Collection of it allows you to pivot to what you need, do stats that you otherwise can't do. And, you saw 11 minutes in my case, and you're done. So there's the chicken nugget recipe. It is excellent. I highly recommend it. I say a pressure fryer, but use a regular fryer, and it works just fine. Don't try to build a pressure fryer. It will explode. And so, I appreciate it very much. Here's some detail, and any questions, see me after or whatever. Right now, I think I'm probably over time. And there you go.